Hey guys. Okay, so I gave you guys a video a few minutes ago. Well, you're probably watching that a while back. But the video initially that I gave you was about how to find your e-textbook because I think that's really important. The other thing that I want to go over real quick is your workbook. So everybody got a workbook, looks like this, okay? So notice the workbook is slightly different than the cover of your textbook. Okay, so, but they're the same. They're the same. This was an old cover, and as they add more technology and things, they just change the cover and a couple other things. So I am going to tell you now, this is set up in what we call the Cornell Notes method. So basically you put all of your notes and questions over here on the left column, and then you fill in anything else with the information in the middle. So for the last section, we went over 1.1, Introduction to Chemistry. And basically, it walks you through how to take Cornell notes. So I don't think that's the right direction. Give me 1 second. So just kidding. Here we go. The text or the workbook has an area for notes, and then it's going to walk you through what you need to do. This is an excellent way to take notes if you'll pay attention to my video lectures, and then you'll go back and write the notes as they're used. The textbook is what you want to use to make sure you fill it in as best as possible. Some of the words don't exactly follow, but it's really, really good for you. So I highly recommend you using those. And the next thing we're going to get into is 1.2. Okay, so section 1.2, everybody should be on page 9. If you haven't already gone through in your workbook, go ahead and do that. That's a really good place to start. It kind of gets you familiar with what we're going to talk about, and then you don't have to sit there and jot everything down while I talk. All right, so let's go. We're going to talk about chemistry and matter. You're going, what? Chemistry and matter. So the main idea in this section is that the branches of chemistry involve the study of different kinds of matter. So there are a lot of branches of chemistry. What we're doing this year is scraping the surface. We are barely tapping into what's out there for chemistry. So I need you to be very open-minded about this part, and I need you to write down your KWL. What do you know about the branches of chemistry? Do you know any branches? Blah, 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 chemistry, blah, 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 chemistry. There are a lot of them, but you may not be familiar with any of them, and that's okay. Tell me what branches of chemistry you know, and if you do know some, what do you think they study? Under your W, what do you want to know? What are you curious about? Whatever this term means, how many there are, just jot something down, and then we'll try to come back to what I learned. What did I learn in this section? And hopefully we answer that on the next slide. So pause if you need more time. Your essential questions. How do mass and weight compare and contrast? Why are chemists interested in a submicroscopic description of matter? And what defines the various branches of chemistry? So, your new vocabulary, your review should be technology, which again is on page 9. It's in the yellow section on the left. It says technology is a practical application of scientific information. So if you didn't know that definition, just add it. It's no big deal. And the new definitions that you'll get, that you'll jot down, are going to be mass and weight and model. And in your workbook, there's a section to put all of those. So if you are the type of person that likes to write really, really neat, you're going to put a bunch of stuff on a separate sheet. But if you're okay with it being slightly messy and maybe crumpling it up a little bit or sticking a sheet of paper in your workbook is good, okay? Our goal is just to get through the information and have a better understanding. I'm not here to make you write all the time, but writing does help you remember. Last class, we learned that matter is anything that has a mass and takes up space. So every time we talk about matter, we're talking about anything with a definitive mass that I can get a mass for, and that has a volume that takes up some amount of space. So mass, what in the world is mass? It's a measurement that reflects the amount of matter. So those two go hand in hand. So when I say conservation of mass, and then I immediately say or conservation of matter, it's because they're interchangeable. If it's matter, it has mass. If it has a mass, it is matter. You see how those two kind of go together? So you might want to take a second to write that down. Mass and matter are very interchangeable for our understanding. Pause me real quick though, because when I go into weight, it's a whole different ballgame. Okay, so weight. This is a biggie, guys. Weight is very important. Why is weight very important? And why in the world did it pick that color? Whatever. Weight. Weight is a measure of mass and the force of gravity on an object. Weight can change from place to place, but mass is constant. That's why we use mass in our definitions. That's why if we get to do labs and I ask you to go take the mass of something on the balance, I'm not asking you to take the weight. No matter where you are, the mass will be the same. So our balances are calibrated for our gravitational pull. But mass is technically a measure of matter. It should never change. If I'm here, if I'm on Mount Everest, or if I'm out in outer space, my mass should be the same. My weight's going to be very different though, because I'm not going to have any weight in space. So I am weightless, yeah, right? But I still have the same amount of mass. If I am on Mount Everest, the pull of gravity on me is less because I'm higher up in the atmosphere. So that pull on me is less because I'm not as close to that surface. So gravity is dependent on how close two objects are. So if we're right here at sea level, we're roughly at sea level, our weight is going to be one number. If I go up to Mount Everest, my weight is going to be another number. If I went down into the Mariana Trench, which is like the lowest point we've ever recorded, closest to into the Earth's mantle and core and, you know, furthest down, I'm closer to the center of gravity, so my mass would be, my weight would be more. But no matter where I am at these points, my mass is the same. The amount of matter in my body is the same. So when we're talking about it and you say weight, I'm going to get mad. It's not weight. We're talking about mass. We're talking about how much matter is in that object, because that's what we're studying, the matter, not the gravitational pull. That is physics. Ugh. Okay? We're talking about matter. We're talking about mass. I'm putting stamps on everything now. Okay. So what is matter? Matter and its characteristics. This is a new subheading, in case you didn't notice. If you look at page 9 in your text, this is the subheading. Real quick, I do want to go over that Chem for You. It's going to apply to the end of this section. So if you will, the Chem for You is basically how does this apply to me in my life? The Chem for You section says chemistry is sometimes called the central science. Research and technology, such as greener energy and cures for disease, rely on chemistry. Even when you brush your teeth or digest your breakfast, important chemical processes are at work. You never get away from chemistry, guys. The act of aging is chemistry, and it's, truly it's biology, but chemistry is what helps the process along. So chemistry is all around you, and when we're talking about matter, we're talking about this year, the very tiniest parts of it. So what we encounter every day, aging, eating food, starting your car, running, all of those things are types of chemistry. And it's all macroscopic. You don't have to think much about it. It can be observed without a microscope. That's what macro means, large, big. I can see it, scopic. I can see the big things. But what we're studying this year is the structure, composition, and behavior of matter. And we have to get to the submicroscopic or the atomic level. So you can't even see atoms with a microscope. That's why we say sub, below. It's even smaller than what I can see through a microscope, because atoms, as you hopefully know, are so tiny. They're so itty bitty tiny little things. So the entire part here is that what we're studying this year, you can't see with your eyeballs, okay? And chemistry explains events on the atomic level, so those tiny submicroscopic levels. And we're talking about how that leads to macroscopic observation. If I pour baking soda in with vinegar, I can't see what's happening on the submicroscopic scale. I can write it out and I can show it with pictures, but I can't see it. But I can see the foam. I can smell the gas that's coming off of it. All of that is called macroscopic observations. I can see the results of it and I can see the process happening, but I can't see the actual changes occurring because they're submicroscopic. This is a biggie. Make sure you get a model. A model is a verbal, visual, or mathematical explanation of an experimental data. A model, didn't mean to do that. A model is a verbal, visual, or mathematical explanation of experimental data. So it's basically, I'm going to explain to you what's going on with this data. I'm going to show you with pictures, or I'm going to give you an equation or a graph to explain this data. How do I show you what's going on? That's called a model. Ooh, that's a lot of words right there. All right, so chemistry. And our old textbook was called Chemistry, the Central Science. Now it's called Chemistry, Matter, and Change. It's just the same thing. So a basic understanding of chemistry is central to every science. What we've done over these past couple of years is we've taken this and we've tried to interweave the chemistry and the biology and the ecology and earth science, and we tried to put every bit of that together so that you don't walk into chemistry, bam, that's the first time you hear about atoms, elements, molecules, and all of that. We're trying to do a little bit better about that so that you have these understandings and we can weave them together so that you get kind of what science is. The hard part is chemistry requires specialization. So just like math, in math you have all sorts of different fields. In literature there are all sorts of different fields. In history there are different fields, and in chemistry there are different fields. So here are the different fields. I'm going to give you just a second and I want you to read through these different fields. If you ever are unsure of how to pronounce these, ask me. I can record myself saying it in my slight twang and hopefully it'll make sense to you. Okay, so let me introduce you to the one that I studied. I studied biochemistry. This was what my degree is in. Biochemistry and cellular and molecular biology, biochemistry, cellular and molecular biology was what my degree was in. So I had to study physical chemistry. No, didn't want to do that. I had to study organic chemistry, inorganic chemistry, and they threw in some thermo. I did not take analytical chemistry. Thank goodness, that was terrifying. Environmental was woven through, and I did not take any of these other ones on the right. So obviously I am not a full-blown chemist, but I have a pretty good background in chemistry. And if you have any questions about these, your textbook is a great source, but we'll get to that in a little bit. All right, so the next thing we're going to do is I want you to take a few minutes before we start this, and you're going to go to page 11. Hopefully you know what page I just said, page 11. And I want you to look over those branches. What is their area of emphasis, and how is that maybe used? So that examples. So go to that part, look through that for a few minutes, and then I'm going to show you how to get to your what we call homework. And it's just assign stuff through your online textbook. So take a minute, and then I want you to push pause, and then we're going to go do this. Okay, hopefully you're with me. So the first thing, you got to open up Clever and that textbook, McGraw-Hill, which opens your textbook, because if you have multiple McGraw-Hill books here at school, they're all going to sit there. And obviously we're in chemistry right now. And then once you get in, we're going to go and we're going to click on the menu. I say we're going to. Okay, so here we go. Please log in again. Ouch. Okay, so once you're in Clever again, you're going to click McGraw-Hill. It's going to sign you in. You're going to click on your textbook. Once you click on your student edition, you're going to click right here. Once you do that, it's going to open up this page. Now, normally we go to the ebook. We're not doing that today. We're clicking menu, and you're going to click homework. Now, in this section, it's going to show you your stuff. If you may have to click on these little arrows because sometimes the things don't look exactly correct, but let me show you what my end looks like. I get professional development, just so you know. So I go to the same pencil, but mine says assignment tracker, and you're doing section that should say 1.2 interactive table. And right here, you'll see it, and you'll need to click over here on the right, okay, and you'll pick it up. So this is just for this class. Make sure that you're doing the interactive table, and when you get finished, be sure you turn it in or click complete for me, okay? So make sure once you're done with it, you've got it all in the right spot, click complete, and that'll be the end of that assignment, okay? So go ahead and do that assignment, and then come back to this video, push play again, and I'll be ready to roll on the next part. Okay, so we've done the, we have done the interactive table for section 1.2, which I typed in 2.1, sorry about that. Let's go back to our essential questions. This is the last little bit that you've got to do. You've got to answer these essential questions. So, how do mass and weight compare and contrast? Why are chemists interested in the submicroscopic description of matter? What defines the various branches of chemistry? You got your textbook. You can record or rewind this video, and you can go back and see what I said. And I really need you to spend some time to think about that. How are mass and weight different? What did we talk about? Why do we care about what's happening at the submicroscopic level? Why can't I just look at the macroscopic? Why is that not important? I feel like that's a big deal. And then what defines those branches? What's different in biochemistry versus analytical chemistry? Why are there different fields? So sit on those for a minute, answer my questions, and you have a great day.